In 1905, a 26-year-old patent clerk sat in a small office in Bern, Switzerland, and wrote down a number. Not a discovery about light, not a theory about stars or telescopes. A number. 299,792,458 meters per second. And with that number, he quietly ended the universe you thought you lived in. You've heard this number before. Maybe in a classroom, maybe in a documentary, maybe in a meme about how nothing can go faster than light. And if that's what you think this number means, that it's a speed limit for light, I need you to stop believing that for the next 20 minutes. Because it's wrong. Not wrong in a nitpicky technical way. Wrong in a way that, once you see it, you will never look at a flashlight, a sunset, or a GPS signal the same way again. Here's the claim this video is going to prove. Piece by piece, with evidence you can check yourself. The speed of light was never about light. It's about something far stranger sitting underneath the light, something that governs cause and effect themselves. And by the end, you're going to understand why physicists don't even like calling it the speed of light anymore. They have a different name for it. We'll get there. But first, you need to see the trap, because almost everyone falls into it, and the trap is exactly why this myth has survived for over a century. Picture this. You're standing in a dark field. You turn on a flashlight. The beam shoots out, and somewhere in your head a little voice says, "Light is fast, but it's still just traveling. Like a bullet, just faster. Like sound, just less draggy." That mental model, light as a very quick object moving through empty space, is intuitive, comfortable, and almost completely misleading. Because here's the first crack in that idea. If light were simply a fast thing, its speed should change depending on how fast you're moving when you measure it. That's how literally everything else in your experience works. Throw a ball forward from a moving car and it goes faster than if you threw it from a car standing still. Basic, obvious, Newtonian. It's how velocities have added together for the entire history of human experience. Except light refuses to play by that rule. And the experiment that first proved it wasn't run by a theorist. It was run by two American physicists in a basement in Cleveland, Ohio in 1887, trying to catch the Earth in the act of moving through space. Albert Michelson and Edward Morley believed, like almost every scientist of their era, that light traveled through an invisible medium called the luminiferous ether, the way sound travels through air. If that were true, then Earth hurtling through space at roughly 30 kilometers per second should create a kind of ether wind. Light moving with that wind should travel faster. Light moving against it should travel slower. It's the same logic as swimming with a current versus against it. So they built one of the most sensitive instruments science had ever seen, an interferometer that could detect tiny differences in the speed of light by splitting a beam, sending it in two directions, and recombining it to look for interference patterns. If the ether existed, the patterns would shift depending on the direction Earth was moving relative to the ether wind. They ran the experiment. They ran it again. They rotated the entire apparatus to rule out equipment error. And the result, again and again, was nothing. No shift, no wind, no ether. Light moved at exactly the same speed, no matter which direction they measured it in, despite Earth hurtling through space at tens of kilometers per second in an ever-changing direction throughout the year. This is where most retellings of this story stop and just say, the ether doesn't exist, isn't that neat? But that undersells how genuinely disturbing this result was. Michelson and Morley didn't just fail to find a medium, they accidentally proved that light doesn't behave like a moving object at all. It behaves like something built into the fabric of measurement itself. And nobody, not Michelson, not Morley, not the physics community for almost 2 decades, knew what to do with that. But before we get to the patent clerk, you should know that the idea of light having a measurable finite speed at all was itself a hard-won discovery, and it happened over 2 centuries before Einstein was born. In 1676, a Danish astronomer named Ole Rømer was studying Io, one of Jupiter's moons, timing its eclipses behind the giant planet. He noticed something odd. The eclipses didn't arrive exactly on schedule. When Earth was closer to Jupiter in its orbit, the eclipses happened slightly earlier than predicted. When Earth was farther away, they happened slightly later. Rømer's explanation was radical for its time. Light wasn't instantaneous. It took time to cross the extra distance, and that delay was showing up in his measurements. Using the numbers available to him, he estimated the speed of light at roughly 220,000 kilometers per second, off from the true value, but the right order of magnitude. And more importantly, the first time in human history anyone had proven light wasn't simply everywhere at once. That single insight, that light takes time to travel, sat quietly in physics for over 200 years before anyone realized it was the thread that, if you pulled on it hard enough, would unravel the entire structure of space and time itself. Ask yourself this before we continue. If a 17th century astronomer looking at Jupiter's moons could already tell you light wasn't instant, what took physics another 230 years to notice the far bigger implication hiding inside that fact? Then came the patent clerk. Einstein's insight in 1905 wasn't really about light at all, and this is the reversal that this entire video hinges on, so stay with me. Einstein didn't ask, why is light so fast? He asked a much stranger question. What if the speed of light is constant for every observer, no matter how they're moving, and everything else, space, time, simultaneity, has to bend to make that true? That's backwards from how you'd normally think about it. Instead of asking what light does, Einstein asked what the universe would have to look like if light's constancy were the fixed rule, and everything else was negotiable. And when you run the math on that assumption, something extraordinary falls out. Time stops being universal. Two events that are simultaneous for you might not be simultaneous for someone moving relative to you. Space contracts, time dilates, mass and energy become interchangeable. All of it, the entirety of special relativity, falls directly out of one single premise, that this speed, this 299,792,458 meters per second, is not a property of light. It's a property of causality. Let that sit for a second, because this is the actual reveal you came here for. Light travels at this speed because light is massless, and anything massless is forced to travel at the maximum speed the universe allows for cause to reach effect. Light isn't setting the speed limit. Light is just the fastest thing we know of that's obeying a speed limit that already existed, independent of light entirely. Physicists have a name for this that has nothing to do with photons. They call it c, not for light, but originally proposed to stand for constant, and increasingly understood by physicists today as the invariant speed of causality itself. It is the maximum rate at which information, influence, or cause and effect can propagate through space-time. Light happens to travel at that speed because photons have zero rest mass, but gravity does too. If you could somehow instantaneously delete the sun right now, Earth wouldn't feel the gravitational change and lose its orbit until roughly 8 minutes later, the exact same delay as sunlight reaching us. Not because gravity is light-like, because gravity, like light, cannot exceed the universal speed of cause and effect. This is the moment to ask yourself something. If gravity has nothing to do with light, and yet it's capped at exactly the same speed, doesn't that tell you the cap was never about light to begin with? That's your reality check for this file. The myth says light is uniquely, specially fast, and everything else is slower by comparison. The reality is that light is not the rule setter. Light is just one of several phenomena, including gravity, including anything massless, that are all obeying a single underlying limit built into the structure of space-time itself. The myth makes light the main character. The evidence makes light a witness to something much bigger. So if it's not about light, what is it actually about? This is where the story gets even stranger, and where I want you to really lean in, because most explainers stop at relativity says time slows down, without ever showing you why that isn't some cosmic inconvenience. It's the universe protecting a much deeper rule. Causality has to stay consistent for everyone, everywhere, no matter how they're moving. Here's the version of this that should genuinely unsettle you. If anything, information, an object, a signal, could travel faster than c, you could construct a scenario where an effect happens before its cause, depending on who's observing it. Not hypothetically, mathematically. Special relativity shows that if faster than light signaling were possible, there exist valid reference frames in which someone receives a message before it was sent. Cause and effect would become observer-dependent, which is another way of saying the universe would stop making logical sense. The speed limit isn't there to inconvenience spaceships. It's there so that the phrase, "this happened and then that happened," means the same thing to every observer in the cosmos. And this is why the label speed of light is, honestly, a historical accident. We named it after the first thing we happened to measure moving at that speed. In the same way you might name a law the speed of sound, if sound happened to be the first thing you clocked at 343 meters per second. except sound speed depends on the medium it's traveling through, air versus water versus steel, while c does not depend on any medium at all, because it isn't describing a substance moving through space, it's describing the geometry of space-time itself. Let's make this concrete, because I know abstract space-time geometry can start to feel like word soup. You use this speed of causality, this so-called speed of light, every single day, and it has nothing to do with staring at a light bulb. Every time you use GPS on your phone, you're relying on satellites in orbit carrying atomic clocks so precise they can detect nanosecond level differences in time. And because those satellites are moving fast relative to you and sitting in a weaker gravitational field than you are, their clocks tick at a very slightly different rate. Both effects predicted directly by relativity. Both effects rooted entirely in the constancy of this speed we misname the speed of light. If engineers didn't correct for this every day, GPS positioning would drift by about 10 kilometers within 24 hours. Your Maps app would put you in the wrong city by lunchtime. This isn't theoretical physics sitting in a textbook. It's a correction factor running silently in orbit above your head right now, keeping your rideshare app from sending your driver to the wrong street. Or take muons, subatomic particles created when cosmic rays slam into Earth's upper atmosphere, roughly 15 kilometers up. Muons are famously short-lived. Left alone, most of them decay in about 2 microseconds, nowhere near enough time to survive the trip down to the ground at any reasonable speed. And yet, detectors at sea level pick up muons constantly. How? Because those muons are moving at a significant fraction of c, and at those speeds, time dilation stretches their effective lifespan from the perspective of an observer on the ground. From the muon's own reference frame, it experiences a contracted distance, arriving well within its short lifetime. Either way you describe it, stretched time or shrunk space, the underlying cause is identical, the invariant speed limit reshaping the geometry of the trip. This experiment has been repeated in physics classrooms and research labs for decades, and it works exactly as predicted every time. I want you to notice something about both of these examples. Neither one is really about light. GPS satellites aren't emitting visible light beams for you to watch. Muons aren't glowing streaks racing toward the ground. These are demonstrations of the underlying causal speed limit showing up in completely different physical contexts. One in electronics and orbital mechanics, one in particle decay, and both obeying the exact same number, because the number was never about light to begin with. It's about the rulebook the entire universe runs on, and light is just one of the ways that rulebook becomes visible to your eyes. Now here's where I have to be honest with you about something people often get wrong when they hear this, because I don't want to leave you with a curiosity gap that turns into a misconception. Remember, that's not how this channel operates. You may have heard claims about quantum entanglement communicating faster than light, and I want to correct that directly right now, because it's one of the most common physics myths circulating online. Entangled particles do show correlations that appear instantaneously, regardless of distance, but no usable information, no message, no signal, nothing that could violate causality, can actually be transmitted faster than c using entanglement. Multiple rigorous experiments, including long-distance entanglement tests conducted with satellites in the 2000s, have confirmed the correlations while confirming, just as firmly, that no faster-than-light communication is possible. The causal speed limit holds. It always holds. Every experiment we have ever run, across more than a century of increasingly precise instruments, has failed to find a single verified exception. There's one more piece of evidence you need to see, because it's arguably the moment the whole world was forced to take this idea seriously. And it happened just 4 years after Einstein finished the general theory. In May 1919, British astronomer Arthur Eddington led an expedition to the island of Principe off the coast of West Africa to observe a total solar eclipse. His goal was to test a specific prediction. General relativity said that massive objects like the Sun should curve spacetime enough to visibly bend the path of starlight passing near them, meaning stars close to the Sun's position in the sky should appear slightly shifted from where they'd normally be, but only during an eclipse, when the Sun's glare wouldn't wash them out. Newtonian physics predicted a bend too, but a smaller one, roughly half the size Einstein's equations demanded. Eddington photographed the stars near the eclipsed Sun, compared their positions to photographs taken months earlier when the Sun was elsewhere in the sky, and measured the shift. The result matched Einstein's number, not Newton's. Headlines around the world ran the story within days. A patent clerk's decade-old thought experiment about clocks and trains had just been confirmed by starlight bending around the sun, observed from a small island most people had never heard of. And this is worth pausing on, because the sun-bending starlight has nothing to do with light being special either. It's gravity curving the actual geometry of space-time, and light, having no choice but to travel through that space-time at the universal causal limit, simply follows the curve it's given, the same way a ball rolling across a warped table follows the table's shape rather than choosing its own path. The light isn't being pulled off course by some magical light-specific force. It's tracing the shape of a universe that gravity itself had already bent, using the exact same invariant speed that shows up in GPS satellites, muon decay, and Einstein's original 1905 postulate. 3 completely different experiments run across 3 completely different domains: orbital timing, particle physics, and starlight during a solar eclipse, and every one of them points back to the same underlying rule. That consistency is itself remarkable if you stop and actually sit with it. We've tested this constant using laser interferometry, using particle accelerators smashing protons together at 99.999991% of C, using 9991% of C, using astronomical observations of supernova and gamma-ray bursts billions of light years away, using atomic clocks flown on airplanes, using the exact GPS system sitting in your pocket. Before I list the rest, take a guess. How close do you think engineers can push a proton to the causal speed limit before the energy required becomes effectively infinite? Most people assume there's plenty of room left. There isn't. At CERN's Large Hadron Collider, protons are accelerated to within a few millionths of a percent of C, and yet, no matter how much additional energy is pumped in, they never cross it. Each additional burst of energy buys a smaller and smaller sliver of extra speed, because as an object with mass approaches this limit, the energy required to accelerate it further rises without bound. This isn't an engineering shortfall. It's the equations of relativity showing their work in real time, inside a 27-kilometer ring buried under the border of France and Switzerland. Every collision recorded there, every particle detected, is additional confirmation of the same underlying limit, gathered not from light at all, but from protons, particles with mass, doing everything they can to approach a boundary they are mathematically forbidden from crossing. And this is where the astronomical evidence becomes almost eerie in how well it lines up. Gamma-ray bursts, some of the most energetic explosions in the universe, are so distant that the light reaching our telescopes today left its source billions of years before Earth even existed. Astronomers have compared the arrival times of different wavelengths of light from the same burst, reasoning that if the causal speed limit varied even slightly by energy or wavelength, the different wavelengths would arrive at slightly different times after a multi-billion-year journey, and that difference would be measurable. Across dozens of observed bursts, no such variation has ever been detected beyond the precision of our instruments. Light of every color, having traveled for essentially the entire age of the observable universe, arrives together exactly as this single invariant limit predicts it should. Different methods, different errors, different teams of scientists on different continents with no coordination between them, and every single one converges on the same number, the same limit, the same underlying rule. That's not the kind of agreement you get from a coincidence. That's the kind of agreement you get when you've found something load-bearing in the actual architecture of reality. Which brings us to the human cost of this idea. Because accepting this wasn't easy, and it wasn't free, and the person who paid the highest price for it wasn't even the one who's remembered for it. Hendrik Lorentz, the Dutch physicist whose equations Einstein would later build on, spent years trying to preserve the ether. He derived the exact same mathematical transformations Einstein would eventually use. The Lorentz transformations still bear his name, but Lorentz kept trying to interpret them as a strange, real physical effect of objects moving through a real ether, some kind of mechanical contraction, rather than accepting what Einstein saw clearly, that there was no ether to move through at all. Lorentz had the math. He didn't have the nerve to let go of the old picture of the universe. He spent the back half of his career defending a framework that the evidence had already quietly dismantled, because the alternative meant accepting that space and time themselves were not fixed absolute stages on which the universe played out. They were flexible, observer-dependent, woven together into a single fabric. And Einstein himself wasn't spared the emotional weight of this either. In private letters, he described the years leading up to general relativity, the extension of these ideas to gravity itself, as some of the most mentally exhausting of his life, wrestling with the mathematics of curved spacetime for the better part of a decade after his original 1905 insight. This wasn't a flash of genius delivered painlessly. It was a grinding, uncertain confrontation with the possibility that his own first version of the theory was still incomplete, that gravity itself had to be folded into this same causal structure before the picture would actually hold together. There's a quieter tragedy in Lorentz's story that rarely gets told. He wasn't a stubborn man clinging to outdated ideas out of pride. By every account, he was one of the most respected, careful, and generous physicists of his generation. Einstein himself would later call Lorentz the greatest and noblest man he had ever known personally. Lorentz mentored younger physicists, corresponded generously with rivals, and built the exact mathematical scaffolding that special relativity would eventually stand on. But he built that scaffolding while still trying to hang the old ether-based universe from it, refusing or perhaps simply unable to take the final conceptual step Einstein took almost effortlessly by comparison. It's a strange kind of scientific heartbreak, to construct nearly the entire building and then watch someone else walk in and correctly identify what it was actually for. And Einstein's own path here deserves more nuance than the popular image of the effortless genius scribbling equations on a chalkboard. The stretch of years between his 1905 paper on special relativity and his 1915 completion of general relativity was defined by repeated failure, backtracking, and long stretches where he wasn't sure the mathematics would ever cooperate with the physical intuition he was chasing. He needed help from mathematician friends, particularly Marcel Grossmann, to master the tensor calculus required to describe curved spacetime rigorously. In letters from this period, Einstein described feelings of near total exhaustion, at one point writing to a colleague that compared to the problem of gravity, the original problem of relativity was child's play. This is a useful thing to sit with the next time a formula in a textbook looks clean and inevitable in hindsight. It rarely was. Behind almost every tidy equation is a person who spent years lost, wrong, and uncertain before the picture resolved. That's the real story hiding underneath this number. It's not just a fact you memorize for a physics quiz. It's the record of scientists being forced, one stubborn piece of evidence at a time, to abandon the comfortable idea of an absolute universe, one universal clock, one fixed stage, and accept a far stranger, more unified structure where time, space, and causality are bound together by a single invariant speed that has nothing to do with light and everything to do with the logical consistency of reality itself. So where does this leave us today, in 2026, with all of this settled and confirmed 1,000 times over? It leaves this constant sitting quietly underneath almost every piece of advanced technology you interact with. Fiber optic communication, satellite timing, particle physics research, even the models astronomers use to interpret gravitational wave detections from colliding black holes, first directly observed in 2015, all of it rests on the same premise Einstein proposed in that Bern patent office. Every gravitational wave signal we've since detected has arrived exactly on schedule, exactly at the speed predicted, exactly consistent with a limit that isn't about light, was never about light, and yet gets light's name stapled to it in almost every textbook you'll ever read. Take a moment and actually try to hold all of this at once. A 17th century astronomer noticing Jupiter's moons were running on the wrong schedule. 2 Americans in a Cleveland basement failing to detect a wind that didn't exist. A patent clerk who decided the failure was the answer, not the obstacle. A Dutch physicist who built the correct math and still couldn't let go of the wrong picture. A British astronomer photographing starlight bent around the sun during 4 minutes of total darkness on a small African island. Satellites above your head right now, correcting their clocks by fractions of a second so your phone doesn't misplace you by kilometers. Protons in an underground ring in Switzerland, refusing, no matter how much energy you feed them, to ever quite reach the line. None of these people were in the same room. Most of them were separated by decades, some by centuries. And every single result they produced points at the exact same number, the exact same rule, arrived at from completely independent directions. That's not what a coincidence looks like. That's what it looks like when a species slowly, stubbornly, uncovers something that was true long before anyone was around to measure it. I want you to walk away from this video with a very specific reframe, because that's genuinely the entire point of this channel. The next time someone says, "Nothing can go faster than the speed of light," I want a small voice in your head to correct them, gently. It's not about light, it's about causality. Light is just the messenger that happens to travel at the maximum speed the universe allows, the same speed gravity uses, the same speed every massless particle is forced into, the same invariant number woven into the geometry of space-time that both Einstein and Lorentz stumbled toward from different directions, one with the courage to accept it and one without. Before you go, I want to be straight with you about something, because that matters more to me than any algorithm. Videos like this take weeks of research, cross-referencing peer-reviewed relativity papers, historical archives from Einstein's correspondence, and experimental data from GPS engineering documentation before a single word of script gets written. If that kind of evidence-first approach is something you value, a super thanks genuinely helps keep this channel independent and add light. No pressure at all, just wanted you to know the work that goes into getting this right, especially on a topic where it's easy to oversimplify and end up spreading the very myth this video was built to correct. And speaking of getting things right, there's a much stranger question hiding right behind everything we just covered. One I deliberately didn't touch today. If causality has a speed limit, and light simply obeys it, what happens to that limit in the one place in the universe where space-time itself is torn open? Inside a black hole's event horizon, where physicists' own equations start producing answers that look less like a boundary and more like a contradiction. That's the next file. I'm not resolving it here. Comment your best guess before the next upload. I read every one, and I want to see how many of you land close to what the evidence actually shows.